This video will serve as a beginner's process, so to speak, to understand how to put different nonmetals together to form covalent compounds, and we call this covalent bonding. And we are going to be able to see how covalent bonding works. First of all, we are going to go to the internet and take a look at a wonderful animation from ChemThink. So covalent bonding is typically explained as a bond that forms when atoms are sharing electrons. In this tutorial, we will explore what this means and how the process of sharing electrons can hold two atoms together. So here's two atoms. These are both hydrogen atoms, and I'm going to move them for you to show you what happens. And I want you to watch over here, and what you're looking at over here is one electron going around one hydrogen atom and its random motion and distance from that nucleus. Okay, the nucleus of course is only one proton. So I'm going to move the other hydrogen atom close here, and now watch closely. Look at the motion of those atoms. Okay, it's changing dramatically. Not the atoms, the electrons. Ooh, did you see how they kind of bounced together and finally settled in the middle? You'll notice that what's going on in the middle there is a tug-of-war. And basically it's like magnets in motion. The one side of the magnet is the electrons, and the other side of the magnets are the protons, or the nuclei of the two atoms. And it appears that these guys are drifting right now. Let's pull them back toward the center of the screen. And you can see that motion, that sharing of electrons is actually a tug-of-war. And we're going to see in future ones. But before you continue, be sure you know the answers to the following questions. How is the movement of the electrons different when the atoms are close? And you should be able to say that now. If not, back this up and watch again. What happens if you try to move the atoms very close to each other? And that's something that I need to show you right now, because I haven't shown you that yet. So let's try and move them together. Yeah, they don't really want to get closer together, do they? See, we can jam them a little bit, but then they're always going to settle at just about exactly the same distance. Okay, so let's move on. Let's look at what happens in a couple of different ways. In the image below, a line has been added showing the attraction that the nucleus on the left has for its own electron. The atom on the right has the same attraction for its own electron, but we don't see this little line like we do in the guy on the left. Now we're going to go ahead and move these guys a little closer, and you can see how that dramatically changed the way that the electron over here was moving around its atom. And it also changed the movement on this atom. Let's see if we can go a little closer. Yeah. And now we are hooked up in that absolutely ideal distance, and both atoms are tugging, but you can't see the lines of force. That's what these lines are, like in physics, if you know anything about physics. The physics lines of force are very similar to this. And let's go ahead and add the lines now for the other guys. There we go. Now they're both tugging on the same two electrons, and it's a little easier to see exactly what's happening here. The distances for each electron change a little bit, and their positions change a little bit, but they are pretty much stuck between those two atoms, and that is the cause of the bonding. The bonding is that this atom's nucleus is grabbing the electrons from this atom as much as he can, and this atom's nucleus is trying to grab the electron from this atom. And so it's a real tug-of-war that's constantly going on between them. So the forces are going both ways, and that's what drives them together, because they're being driven together by the attraction that they both have for those two electrons. And that's good to have two electrons because it makes them look like a noble gas, helium. And sharing is all about getting noble gas configuration, just like we did with ionic bonding. Now let's take a moment. What kinds of atoms are going to do bonding? Well, I'm going to click here and make a mistake on purpose. These are the noble gases. They do not form covalent bonds. They don't form any kind of bonds. So then in the little tutorial here they say, sorry, the noble gases almost never form bonds. They have a strong attraction for their own electrons, but don't tend to take electrons. And likewise, the metals that are over in this area, they're not likely to form any kind of covalent bond, but they do form ionic bonds. And so, sorry, metals hold on to their electrons very well. That's why they form positive ions and are good conductors. So when we clicked in here, you got it. The nonmetals tend to be good at taking electrons from other atoms. Okay, and that's from themselves, among themselves as well. Whoever has the greatest electronegativity, which we're going to learn about more, greatest electronegativity is the one that has the electrons the most, or closest to them. And so here's where our covalent bonding activity is going to wind up being. All the atoms that are in here would be covalently bonding if they come together. And as we add one more here, you can see hydrogen is also a nonmetal and will form covalent bonds. So let's take a look at covalent bond from a different point of view. We're not going to do that. I'm going to continue right into building ionic molecules and show you how that's done. So we're going to go back to the screen that we just left, and we're going to go on and actually build molecules. But first of all, you have to know two very important rules. Fortunately, there's not that many. Okay, all atoms must have 8 of the available valence electrons. That's called the octet rule. You're going to understand that better as I go a little further, so I'm just going to leave it at that. And at the end meaning after you have the entire molecule put together and you think you've got your Lewis structure right, the second thing that has to be correct is the total of all the valence electrons that have been used. Got to have that right. Can't have more, you can't have fewer or less. So let's go on and let's actually build some stuff. Since bonding is all about the electrons, what we need to do first here is actually look at how the molecule is put together and what the total number of valence electrons are. So I'm going to start with the figuring of the total number of valence electrons. So in this molecule, we're going to build the water there in the top left corner of the screen. And we are going to have 1 oxygen and we're going to have 2 hydrogens. So for oxygen, if you look on the periodic chart, the column that the element is in tells you how many valence electrons you have. Since oxygen is in column 6 or 16, depending on your periodic chart, we would have a total of 6 valence electrons. For hydrogen, hydrogen's in column 1, and so he has only 1 valence electron, and since we have 2 hydrogens, we will have 2 total valence electrons. And then we're going to add those guys up to get the total number of valence electrons that we have to actually put the molecule together. And that is very fitting because putting molecules together is always done by figuring what's going on with the electrons, because electrons control everything with bonding. And so we're going to call this our total electrons. And I'm going to write electrons short way like that with an E minus. And I'm going to put a box around that because we're going to have to come back to that at the end and check everything out with the rules that I showed you before. So, first thing I want to do is put the molecule together in the way that it is normally thought of to occur. And so I'm using these lines here as literally building sticks to put things together. Each line actually counts for 2 electrons, and they would be bonding pairs, bonding just the way you saw in that little tutorial before we started putting this stuff together. And so I'm going to put my hydrogens here and here. And what I've done is I have constructed the molecule, but I haven't got the right number of electrons yet. So let's see how many I have left. Each of these sticks is going to count for. So these guys here that I'm going to be pointing to, these little sticks, this is 2 and this is 2. So I've used up 4 valence electrons so far. And so what we need to do is subtract those valence electrons from what we had at the total. So I'm going to subtract 4, and these are bonding electrons. Bonding electrons, which always travel in pairs, and we're going to wind up with 4 more, or 4 left, that is, not 4 more. So what I need to do is put in a total of 4, and they come in pairs because that's the way electrons tend to be, and we'll talk about that in another tutorial later. But for right now, I now have put 4 more electrons on there, and let's go ahead and count. I've got 2, 4, 6, 8. Remember, the sticks count for 2 electrons each. So my total electrons, which we saw here, my total electrons are 8, and I wound up with 8, so far so good. Now, did I get the right number of electrons for everybody? Well, this hydrogen can only take 2. He's an exception, and we'll talk about exceptions a little bit later. But now I've got 2 electrons here for this hydrogen, and I have 2 electrons here for this hydrogen. So the hydrogens are happy. They want 2, they got 2. Oxygen is not an exception, so he has to have 8. I have 2, 4, 6, 8. So we have ourselves a good molecule. We have built it properly. Okay, now let's build a molecule for fluorine. Fluorine has 2 atoms in the molecule, and you're seeing him right up here in this corner of the screen. And so let's go ahead and pull 2 fluorine atoms up, and we've got to connect them. We've got to connect them with bonding electrons, which is why we use the stick. Okay, so now the fluorines are bonded together, and I wanted to get my total of electrons first. I should have done that, but let's go ahead and do it now. So I have fluorines, 2 of them. Fluorine is in column 7 or 17, depending on your periodic chart. And it has 7 valence electrons. Because there's 2 fluorines, that makes 14. And so 14 is equal to our total electrons available, total valence electrons available. All right, so now we have to account for the bonding electrons, which are here, and so we're going to subtract 2, and when we subtract our 2, we will come up with a total left of 12, I'm sorry. So the 2 were bonding electrons. All right, so that left us with 12. So here we go. Let's each fluorine needs more electrons, so let's give it to them. Here's 2, 4, 6, 8, 10, and if I can get this to go, there we go, 12. So now we have the 12 put in there, and let's see how many we have total. So we're going to count these guys out and make sure that we come up with the 14 that we had over here as the total electrons. 2, 4, 6, 8, 10, 12, 14. We got the right total. So this requirement is satisfied. We have the right number. Now, does everybody have 8? 2, 4, 6, 8 for the atom on the right, and it's 2, 4, 6, 8 for the atom on the left. Notice where I have the arrow pointing right now, that's the bonding pair. That bonding pair gets counted twice, once for each fluorine. So everybody has 8, and we are great and good to go for our next little guy that we're going to put together. This time we're going to put together nitrogen and 3 hydrogens, which is also known as ammonia. So, before we do that, let's figure out our valence electrons. We have nitrogen, which is in column 5. So, he has a total of 5 valence electrons. And then we have 3 hydrogens, which is going to give us 3 more. And so our total valence electrons are equal to 8. And this is total. I'm just going to abbreviate total electrons. And we're going to put a box around that guy again, because we have to come back here and check that out at the end. Now, let's go ahead and put our ammonia together. Nitrogen is going to be in the middle, which we'll describe the reason for that in another video. But we're going to put this guy together with nitrogen in the middle. Notice if we put hydrogen in the middle of any of these guys, let's say we did this, built them like this, and we take hydrogen as the central atom. Well, that creates a really serious problem. And I'm going to have to point to be able to explain it to you. Here we go. If I can just get this thing to cooperate. Here we go. So nitrogen is connected to this hydrogen. They have to at least share 2 electrons to be bonded. So that gives 2 to hydrogen and 2 to nitrogen before we do anything else. Before we do anything else, there has to be 2 to hook this hydrogen to this hydrogen. Now, that central hydrogen has 4 electrons. And then we'd have to put 2 here, and that would give this guy a total of 6. Not good. He doesn't like that. So, what we do is we put nitrogen in the middle so that we don't overload our hydrogens. And that's a good enough reason for right now. But we'll talk more about why nitrogen is in the middle a little later. It has to do with electronegativity, if you know that. Or if you know what electronegativity is. So, now we've got our guys pretty much laid out the way they ought to be laid out. And let's put in the bonding electrons to hold these guys together, like with little sticks. And there we go with this guy. We're holding that guy together. And, oops, we want to put this guy up here. And here we go. We are all set with our ammonia. He's put together. Now, how many electrons have I used for bonding pairs? See if you can figure that out. Stop the video if you have to, and then come back. Okay, my bonding pairs. How many do I have? I have 2, 4, 6 bonding pairs. So, we're going to put that number up there. We're going to subtract the bonding pairs. Bonding electrons. And we're going to wind up with a total of 2. That's all that's left over. So let's take a 2 and put them up there. And now let's count our total electrons and see if we've made this thing right. 2, 4, 6, 8. And that is the number that we had over here. So we are in good shape so far as total number of electrons. Now, let's look at hydrogen. This hydrogen has 2. This hydrogen has 2. And this hydrogen has 2. So all the hydrogens are happy campers. Now nitrogen is one of those guys that has to have 8. And so 2, 4, 6, 8 for the nitrogen, 2. 2 for each of the hydrogens, and we have ourselves a good Lewis structure. We're confident of that. All right, we're going to move on to what's our last one to put together. And this guy is going to be methane. And there's our methane molecule in the top left corner. And let's go ahead and figure out the total valence electrons before we get started. We got carbon. He's in column 4, and so he has 4 total valence electrons. We have 4 hydrogens. Whoops. Oh, I messed that up. Let's get that right. There's 4 of those guys. And hydrogens are going to be 4 because we have 1 valence electron from each hydrogen. So again, we wound up with a total of 8 electrons to put this thing together. And these are the total electrons in the molecule. There we go. So let's go ahead and get this started. Carbon is going to have to be in the middle, and you can think of it like we did with the last one. You can't put hydrogen in the middle ever. So he's just one of those little exceptions, and that's one of his exceptional things. And now we got to put this guy together with some sticks, which are our bonding electrons. And there we go. And here we go over here. And pull that little hydrogen in. And one more here. And we've got it together. Now we have constructed methane. And all we have to do now is check to see if our totals are correct and whether we need any more. But we have to know that we have 2, 4, 6, 8 bonding pairs. So let's write that in. Bonding E's is 8, which we're going to subtract from the 8, and we are done. We can't do any more. So let's check it out. Each hydrogen is touching one of the bonding pairs, so each of these hydrogens is quite happy because he only has 2 electrons. Carbon is supposed to have 8. 2, 4, 6, 8. So carbon is happy, and our total electrons, which was over here, are 2, 4, 6, 8. Same as what we counted for carbon. So that's how we do it, folks. I hope you find that doing a molecule that is covalently bonded as a Lewis structure is coming off a little easier for you. Thank you for watching.